Okay, this is working on note sheet number 2. If you remember at note sheet number 1, we were working with the idea that when you multiply two terms that have exponents, we call those powers, if they have the same base, you can multiply them together by adding their exponents, keeping the base exactly the same. Then we have the situation where we have a power raised to another exponent. When we do that, we end up multiplying those exponents to get the same base, don't change your base, to the product of the exponents. And then our third rule says if you're dividing, what you need to do is subtract your exponents. Again, you need to have the same base, and we end up keeping that base as our final result. Okay, I want you to pause the video right now, and I want you to work through number 1 through 6. Okay, I'm assuming you have completed 1 through 6. Take a moment and check your answers, see how you did. I want to look at 7 and 8 with you because now we're going to look at some applications of this concept with our exponents. Hopefully at this point you still remember your area formulas for a rectangle, which means multiply your length and your width. Okay, in this case our length is h times h to the 17th. Our width is h to the 9th. To find that area, we need to multiply those two values. We need to multiply h to the 17th times h to the 9th. That's our length times our width. When we multiply that, we get h to the 153rd. Okay, that's let me take that back. I changed that. We are multiplying here, so that's our first rule, multiplying. We should be adding our exponents. I apologize for that. We get h to the 16th. Okay, that is our expression for the area of the rectangle. Area of a square can be treated exactly the same, or we can use a shortcut formula for area of a square, which says take the length of one side and square it. I'm going to look at it this way. So one side is x to the 8th. The square should have all the same sides. So I take my one side, x to the 8th, and I'm going to square that. Okay, this says I'm taking a power to another power. When I have a power to a power, I multiply my exponents, and I get x to the 8 times 2, which is 16. This is my expression for the area of this square. Okay, that's just some applications of the old material that we have been working on prior to this. Now we're going to look at our new problems. Okay, we're adding a few more rules. They're really just extensions of the previous rules we've seen, but let's go ahead and take a look at them. Here we have a situation where we have two powers raised to a power. Okay, we have this whole quantity to the third power, which means I want this whole quantity multiplied by itself 3 times. That's what that third power means. And that means I'm multiplying all of these together. Remember, parentheses and just writing it next to each other all mean multiplication. Now we have 3a values that are being multiplied together. Remember, we have to have a common base to multiply them together. a to the 4th times a to the 4th times a to the 4th, all multiplying. That's our first rule. If I'm multiplying, I add my exponents. I get a to the 4 plus 4 plus 4, which is a to the 12th. Now I focus on the b's. I have a b squared times a b squared times a b squared. Adding those exponents, 2 plus 2 plus 2 gives me 6, so I get b to the 6th. Okay, I'm going to try that again. Here we have 2 squared times 3 to the 4th power. So I have this whole quantity to the 4th power, so I'm going to multiply that quantity times itself 4 times. And now looking at that, I'm going to do the multiplication I can. Things with the same base, all the 2's. 2 here, 2 here, 2 here, 2 here. There's 8 of those 2's, so I have 2 to the 8th. 3's, I have 1, 2, 3, 4 3's multiplied together, so I have 3 to the 4th. Now that could be multiplied out, but we're going to leave it in exponential form for right now. One last example, hopefully we got the idea. Here it's a whole quantity squared, so I repeat that quantity times itself. Then multiplying that, x times x. Now we know our rule for adding exponents, but hopefully we know by definition x times x is x squared. Then we have our y to the 5th times y to the 5th. Multiplying 5 y's with 5 more y's means I have 10 y's multiplied together. Okay, if we continue to the back side of this, now it's your chance to try. So I want you to pause this video and try these last problems. Okay, hopefully you work those out. Here are your solutions for the first two. Let's talk about the last one. Hopefully you were able to figure out this rule. But recognize that this is a shortcut to what we were doing before. Not a shortcut, but this is an extension of what we were doing before. I'm taking something with a power and raising it to a power. This time there's just multiple bases to work with. So what happens is I want to apply that power to each of the individual powers within the parentheses. And if you remember our rule, if I'm doing power to a power, what do we do with our exponents? Okay, hopefully you're thinking multiply. So I have c to the 12th to the 15th. And then I have d to the 23rd to the 15th. Writing that out, I get c to the multiplying 12 times 15 to the 180th, and d multiplying here to the 345th. I certainly wouldn't want to write out the expanded form for that. Okay, so what the general rule is with distribution in the power of a power property is that if you have a multiple quantities, maybe you have x to the a and a y to the b, and I want to raise that to the power c, I get x to the ac, multiplying those exponents, times y to the ac, again multiplying those exponents. Okay, now here's your chance to try working on these next three problems.